Hi everyone, today we're going to be going over the first part of lesson 6.2, properties of rational exponents. So we saw rational exponents in the last lesson whenever we wrote nth roots of bases raised to powers and we switched those to exponent form, and we saw that our exponent became a fraction or a rational number. And so today we're going to be going over some of the properties of those rational exponents, and they are very similar to properties that you learned for integer exponents back in Algebra 1. So our first property that we'll talk about is the product of powers. So we'll do this property whenever we are multiplying two things together, and notice that these two things have the same base. So they both have a base of A. And so we will use this property when we have the same base, but we have different exponents on it. And what this property says is that when we have that same base, our exponents are going to add. And so if we look at our example, we see 5 to the 1/2 times 5 to the 3/2, and so that's equal to 5 to the 1/2 plus 3/2. We add those exponents together. So you have to use your fraction addition skills that you learned back in elementary school, or I've made a note down here that you could use your calculator or Desmos Scientific to add and multiply fractions if you need to. So 1/2 plus 3/2 will give us 4/2. 4 over 2 is 2, so 5 to the second power is 25. Power of a power is a rule that we apply when we have something raised to an exponent and then we raise that exponent to another exponent. And notice that when that happens, our powers are going to multiply, m times n. So our powers multiply. So 3 to the 5 over 2 raised to the second power, we will multiply those two fractions together, and 5 times 2 is 10. Divide 10 by 2 gives us 5. Then in your calculator, you can put in 3 and raise it to the 5th power, and you will get 243. Power of a product is when we have two things multiplied together, but they have different bases. So these are different bases, not the same base. And then we're taking that product and we are raising it to a power. And so what we can do is basically distribute that power to each of the bases. So in our example, we will take this 1/2 right here, and we will distribute it to the 9 and to the 16. So our powers distribute. And when we do that, we have 16 to the 1/2 times 9 to the 1/2. Well, remember that 16 to the 1/2, that's the same as square root of 16, or you can put that rational exponent into your calculator. You'll get 4. And then 9 raised to the 1/2 power, or the square root of 9 is 3. 4 times 3 is 12. Negative exponents just tell us that we need to do a reciprocal of our base. So if our base is A and it's raised to the negative m power, we take the reciprocal, and then once we take the reciprocal, notice that our power becomes positive. So we get rid of that negative by taking the reciprocal. So for our example, we have 36 raised to the negative 1/2 power. The reciprocal of 36 is 1 over 36, and our exponent becomes a positive 1/2. Well, we know that the square root of 36 is 6, so our final answer is 1 over 6. The zero exponent rule says that we have anything raised to the 0 power, then that thing is equal to 1. And the one little technical thing about it is that A can't be equal to 0. So that is the one little exception. So we can say that it is always equal to 1. Quotient of powers. So now we're dividing. And if we have the same base again, notice that this is an A and this is an A, but we have different exponents, then we can just take that as a single base and subtract our exponents. For our quotient of powers rule, our example says 4 raised to the 5/2 power divided by 4, the same base, raised to the 1/2 power. And notice that we are going to subtract our exponents or our powers. So powers subtract. And so we will have 5/2 minus 1/2, and that's going to give me 4/2. And 4 over 2 is 2. And then 4 squared is 16. Finally, the power of a quotient. So if we have different bases here, A and B, those are different bases, and we are raising them to a power, so a quotient to a power, we can break that up into two separate pieces. So in this example, 27 over 64, well, that's not going to simplify by itself. However, if we take 27 to the 1/3, that's 3. The third root of 27 is 3. 64 to the 1/3 is 4, because 4 times 4 times 4 will give us 64. So sometimes it's advantageous to break these apart and get a final answer. Occasionally, it will be advantageous to take something that looks like this and go the other direction with it. So make yourself a note that these properties can also be used in reverse.